Hi, I'm Mrs. S from Steps to Success Maths. In this video, we're working through exam questions on upper and lower bounds. We're going to start with some easy ones and work right through to the hardest. Pause the video, have a go, and we'll go through it together, step by step. A banana weighs 109 grams to the nearest gram. Write down the lower bound of the mass. So you've got to think of bounds like you think of rounding. You have weighed a banana and you now have to round your answer to the nearest gram. So what could you have got that rounded up to 109? Because we want the lower bound, so we want the lowest number we could have rounded. So the answer is 108.5. Anything less than that would round down to 108, and anything over that is where we want it to go. So 108.5 grams. B, write down the upper bound of the mass of the banana. So you're going to do the same thing and you're going to think about what the biggest number is that you could round, and this time it will be round down, to give 109. So you could have 109.1 or 0.2 or 3 or 4 or 109.45 or 109.499999. But because it gets so close, what we do is we actually say it's 109.5. It's the point where it changes from being able to round down. So the upper bound is 109.5 grams. The speed of a car is 60 miles per hour to the nearest 10 miles per hour. Write down the lower bound of the speed of the car. So same idea. You need to do two things when you're looking at bounds. You need to check if you're going for the lower one or the upper one. And you need to look at the accuracy. So what were you actually rounding it to? Well, this one you were rounding to the nearest 10. So 60 miles per hour. What could the speed have been that rounded to that when you round to the nearest 10? So your choices were 50 or 60. You're looking for the lower bound, so we're going under the number. So at 55, you start rounding up to 60. So the lowest one is 55 miles per hour. And now we're going to write down the upper bound of the speed of the car. So the upper bound, so the two numbers you could have rounded to the nearest 10 was 60 and 70. Where does it change from 60 to 70? It changes at 65. And because 64.99999 is so close to 65, we just say the upper bound is 65 miles per hour. A machine puts sweets into bags. The bags are sold in packs of 10. Each bag weighs 250 grams, correct to the nearest 5 grams. Calculate the greatest possible weight of 10 bags. Okay, so think about what we're doing, because this is a calculation, it's a little bit different. If we did this without any rounding, we would just go how much each bag weighs and times it by the number of bags. But we've got to think about this bit where it says each bag weighs 250 grams, correct to the nearest 5 grams. And we're going to find the greatest possible weight. So we want the highest number, the upper bound. So what's the upper bound of 250 grams? When you round it to the nearest 5 grams. So your choices are 250 or 255 when you're rounding, and you want to fall bang in the middle of those. So that's 252.5. Remember, we always go for where it changes when we're talking about upper bounds. And so we need to do 252.5 times our 10 bags. So that's 2,525 grams. The length of a rectangle is 20 centimetres, correct to two significant figures. The width of the rectangle is 14 centimetres, correct to two significant figures. Write down the upper bound of the length of the rectangle. Okay, so the length of the rectangle is 20 centimetres, correct to two significant figures. What does two significant figures mean? It means you've got to use two numbers and any number of zeros. So here you have rounded it to 20. You could have rounded it to 19 or 21 if it had been nearer to those. They would still be two figures. So what's the biggest number that would have rounded to 20 and not gone to 21? So remember, it's an upper bound, so we're just going to pick the middle of our interval. So that's 20.5. And now we're going to calculate the upper bound of the area. So we find the area of a rectangle by doing the length times the width. So to get the biggest number, the upper bound, we want the biggest number for length and the biggest number for width. We already know the biggest one for length, we just worked it out, it's 20.5. And now we want the biggest one for the width. So the width was also rounded to two significant figures. So it could have been 14 or 15, and we want to know where it changes. So halfway along the interval is 14.5. So we're doing 20.5 times 14.5. Going to use a calculator. And that gives us 297.25. A circle has radius 8 centimetres to the nearest centimetre. A. Calculate the lower bound of the circumference of the circle in terms of pi. So the circumference of a circle is pi times d, where d is the diameter. And we know the radius, and we know it correct to the nearest centimetre. And we want to know the lowest value we could get. So we need the lower bound. So what's the lower bound of 8? Round it to the nearest centimetre. So the nearest centimetre we could have had 7 or 8, and we want the middle of the interval, so 7.5. And then we want the diameter, which is twice the radius, so 7.5 times 2. So pi times the diameter is just 15 pi, because we can give our answer in terms of pi. Part B. Calculate the upper bound for the area of the circle in terms of pi. So the area of a circle is pi r squared. We want the radius, and we want the biggest the radius could be for the upper bound. So it was 8, round it to the nearest centimetre, and we want the biggest. So between 8 and 9, halfway between 8 and 9 is 8.5. So pi times 8.5 squared. Remember, we don't need to work out the pi bit, just the 8.5 squared bit. So that's 72.25 pi. A piece of wood has a mass of 9 grams correct to the nearest gram, and a volume of 12 centimetres cubed correct to the nearest centimetre cubed. Work out the greatest possible density of the wood. Give your answer to 3 significant figures. Okay, so you need to know what density is. And I've popped the little triangle here just to help you remember it. Density is mass divided by volume. Now you're dividing, and you want to end up with the greatest possible answer. So when you have a fraction, to get the biggest answer you can, you want the biggest number you can get on the top of the fraction and the smallest number on the bottom. So we want the upper bound of mass and the lower bound of volume. So the upper bound of mass, the mass was 9 grams correct to the nearest gram. So between 9 and 10, halfway, 9.5. And we want the lower bound of volume. So volume was 12 to the nearest centimetre. So between 11 and 12 is 12.5. Now we're going to use these two numbers for our calculation. Density is mass, 9.5, divided by volume, 11.5. And we're going to write down the answer we get off our calculator, which is 0.82608. And then we're going to use 3 significant figures. So remember, that's 3 numbers and any number of zeros. So that's 826, 0.826. A car travels 250 miles correct to the nearest 10 miles. The journey takes 3 hours and 30 minutes correct to the nearest 30 minutes. Calculate the lowest possible average speed of the car. Okay, so we're talking about speed. So we're going to need to know our speed, distance, time triangle. Speed is distance over time. Looking on the answer line, I can see my answer is going to be given in miles per hour. So at some point, I need to make sure I don't have minutes in my calculation. Now, I want to calculate the lowest average speed. So to get the lowest from a fraction, I need the biggest number on the bottom and the smallest number on the top. So I want the smallest of distance, the lower bound of distance, and the upper bound of time. Let's start with distance. The lower bound of distance, and it was correct to the nearest 10 miles. So that's either 240 or 250, and you want to be in between. So 245 miles is the lower bound of distance. And then we want the upper bound of time. So it was 3 hours and 30 minutes, correct to the nearest 30 minutes. So you want the upper bound, so between 3 hours and 30 minutes and 4 hours. So that's going to be 3 hours and 45 minutes. And then we want to write that just in hours. So it's 3 3/4 of an hour, which is 3.75 hours. So to do our calculation, we're going to use 245 and 3.75. Speed equals distance, 245, divided by time, 3.75. And using a calculator, that's 65.3 recurring miles per hour. It's quite a tricky topic, this one. So that you can keep practicing, I've linked a free worksheet with worked solutions. Don't forget to subscribe to my channel. That way you won't miss out on any of my videos or worksheets as I cover the whole of GCSE Maths.